So it's also important to know where you can have reliable data. So typically, a lot of journals are quite serious. I mean, with the time you will identify that some are really more reliable than others in terms of supporting information. This might also be due to the fact that the people who publish in these papers are established chemists. So some of the papers, obviously, Angewandte Chemie, Chemistry European Journal, so, or European Journal of Chemistry. These are the Wiley journals. Then Beilstein Journal of Organic Chemistry. This is a paper which is publicly accessible, so which I like. Then the ACS journals, which would be ORGLIT, JOC, Journal of Organic Chemistry. So I mean, with the time you will become more and more familiar with them. A journal which I really like is OPRD. Let's see, OPRD. Okay, so it's the Organic Process Research and Development paper. Why do I like this paper? Because it's made, many reactions are from industrials, which means these people really have upscaled and optimized the reactions, and you can be sure that the reactions which are described therein, for example, here in a Kolinkovich reaction, so this is a reaction which sounds more exotic if you hear in the lectures, but you see it actually has a lot of applications in synthesis, so for 3-membered cycles and so on. So let's not waste my time with Kolinkovich. So I just clicked on this by curiosity. But the interesting thing is what you can do is you can look for certain reagents or reactions. So for example, if you want to see like the Rysat reaction, so obviously Rysat could be a name appearing somewhere, but it could be also maybe in the synthesis. So let's see, this looks like some heterocyclic chemistry. Okay, let's look for Rysat. You can see here Rysat indole synthesis. So the Rysat indole cyclization. So a paper which goes back to 1897 is actually cited here. So that's kind of interesting. So really old chemistry used. And here, of course, they will show you how the reaction works. So you can find reactions which really work and work on large scale. And then at the end, of course, here you 220 kilos and so on. So you really have the optimized reaction. So if you want to do a certain reaction and you find a paper in organic process research and development, always use this one because it's reliable. You don't have to use very low scale. You can directly go in 5 to 10 millimoles because usually this is a very reliable journal. So you can also look about certain reagents like LDA, for example, and see under which conditions LDA is used in chemistry. So for example, here they often use commercially available LDA. I think they hardly ever do it themselves. Or here you want to find out under which conditions you should do a certain deprotonation. See, you don't always need minus 80 degrees, minus 40 is also good. Here you have a review about flow chemistry, that's nice too. And so you can learn a lot. So, or here methyl iodide, you've seen it. So you can see how a methylation takes place or of like this acid here, and with quite some good yield. So methyl iodide. Let's look into the PDF. methyl iodide. Let's go to the experimental part. Look for methyl iodide. Haven't seen it. The carbamide. Let's look for iodide. Here, methyl iodide. Here we have it. So you see how such a reaction can be used. You can a sealed vessel, 80 degrees, 7 hours with methyl iodide. Obviously sealed because otherwise methyl iodide will evaporate. Okay, so check out this paper when you want to find out more how you do efficiently use a certain chemically. If you look for a named reaction, here that's really a good reference I can give you. It's like this organic process research and development paper.